Hey guys!
Hey guys!
Are you guys ready for Halloween?
Yeah! And my new sidekick here, Tarantula. And also we're gonna decorate this big pumpkin. So brother, how do you think we'll decorate this pumpkin?
Let's use this magic potion that I have here.
Yeah.
Okay, so it's gonna become extra creepy for Halloween. Ready?
Bloody magic!
Okay, ready?
Yeah.
It's crying blood.
Yeah, it's crying with blood. Maybe its eyeballs are made of blood.
Wow. That was scary, right?
That was really creepy.
I know, right?
Yeah. So what happened?
Here, let me show you. So I have 3 test tubes here. The one on the right contains ferric chloride, the one in the middle contains potassium thiocyanate, and the one on the left contains ascorbic acid and sodium carbonate. So let's add some water and get the reaction going. The water is needed because the reaction only occurs in solution. They can't occur as a solid. So let's add some water to each of these. Now this one is fizzing because the sodium carbonate and the ascorbic acid are undergoing an acid-base reaction. Okay, so first let me show you how to make the blood. So let's pour our ferric chloride solution into our potassium thiocyanate. Ready?
Yeah.
3,
Power.
2,
Blood magic.
1.
Blood, come to me.
Wow.
Ooh.
It turned blood red,
Ooh.
just like here. So what happened? Well, what happened was that the potassium thiocyanate formed potassium ions and thiocyanate ions when dissolved in solution. Similarly, ferric chloride produced iron ions and chloride ions. But what happened when they were mixed was that the iron 3 plus ions and thiocyanate ended up complexing with each other. So what happened was that the iron ion acted as a central atom in the middle, and the thiocyanate just basically stuck on. What formed was an iron 3 thiocyanate complex, and it has this really blood red color.
Bloody. Wow.
But some of you guys might be wondering, how do you clean up this mess? Well, it's pretty easy. All you gotta do is get a mixture of ascorbic acid and small amounts of sodium carbonate. Ready?
Yeah.
Okay, when I add this, it's gonna turn clear. Watch.
Clear. Clear.
Check it out.
That's more like a phoenix now.
So the bloody color, the only thing that's left of the bloody color now is this residue. But if you shake it around enough, it's gonna completely disappear.
Disappear.
To learn more of the chemistry involved, let's go back to our board. See you at the board. Bye!
Bye.
Okay, so now let's go over all the reactions that occurred in a little more detail. So, if you watched our AP Chemistry video series, you may already know that when an ionic compound goes into aqueous solution, it produces its respective ions. For potassium thiocyanate, that would be potassium and thiocyanate, and ferric chloride will make iron 3 ions and chloride ions. The more important ions are iron 3 plus and thiocyanate. The counter ions, which are potassium and chloride, don't actually matter too much here. So it'll still work if you use something like sodium thiocyanate or another iron 3 salt like iron nitrate. It only matters if the iron ion or thiocyanate ion is gone. The other ions don't really matter, as long as it won't interfere with the reaction. So, but in the iron, when it dissolves, it'll bind to the water molecules to form an alkyl complex. Many transition metals, including cobalt, nickel, copper, and many others, can do that. So it'll look something like this. Now it looks weird that we have an iron, and the water is actually considered like an ion. We have parentheses and the base of 6. But that's just how you write complexes. The ligands are put in parentheses and we put a base. So because water is a ligand, we put parentheses and put a base of 6 for our case. But when we add the thiocyanate ions, one of the Y molecules will get kicked off. So therefore, the base of water in the iron 3 thiocyanate complex will be 5. Meanwhile, thiocyanate will bind to the iron 3 plus. Now the reason why the waters got kicked off was because specific ions can only put in specific number of ligands. Because iron 3 plus in particular can only bind to 6 ligands, one of the waters will have no choice but to get knocked off. Meanwhile, the 3 plus charge will add on to the negative 1 charge of thiocyanate to make a 2 plus charge in our iron 3 thiocyanate complex. Also, the iron 3 thiocyanate has a very nice blood red color, so it won't look like it's blood, although it really isn't. Here's the reaction of what happens when you erase the blood. Now this complex actually also featured in the bleeding iron video. You can check it out in the upper right hand corner and in the description. So what we used was ascorbic acid, also known as vitamin C, and sodium carbonate. So what happened was that the ascorbic acid is a very powerful reducing agent. It's also an antioxidant, which is literally the same thing. So 2 iron 3 thiocyanate complex molecules interact with the ascorbic acid to produce iron 2 plus. I may wonder, wait, what's the big difference between iron 2 and iron 3 when they're both iron? Well, the major difference is that their charges are different. Iron 3 plus has a 3 plus oxidation state and is an orange color. Iron 2 plus has only a 2 plus oxidation state and it has a greenish color. Well, the thing is though, iron 2 plus doesn't like to mingle with these thiocyanate ions. It doesn't really like to stick around. So the iron 2 will just go into solution by itself. Thiocyanate will be liberated and also form this byproduct. Ideally, if there were no sodium carbonate, then there would be 5 water molecules liberated and 2 acidic protons. But the thing about acidic protons though is that it might end up binding to the thiocyanate. We don't really want that, so that's why I added the sodium carbonate. It'll react with the excess H plus and produce carbon dioxide and another water. It'll also release sodium ions into solution, but it'll form sodium thiocyanate, which is still in solution. You can also keep adding iron 3 plus and ascorbic acid back and forth, because ultimately thiocyanate isn't actually consumed or anything. It just remains in solution. Now, there's one thing I have to address, and it's that you can't use too much sodium carbonate. The reason is that the iron 2 plus that formed during the reduction can react with the carbonate to form insoluble iron 2 carbonate and iron 2 oxide. So it will form this like purple color, and it's gonna be a big pain to remove. So now let's go back to our lab and finish off the video. See you there. Bye. So that was how to decorate your Halloween pumpkin to make it extra spooky.
Decorate! Thanks for watching, and bye-bye, creepy lovers!
And see you in our later Halloween videos.
Press like, and subscribe.
See you then. Bye.
See ya, and have a nice creepy day.